There are just a handful of approved COVID-19 vaccines around the world, and several more that have the OK for emergency or limited use. Scientists have been working at record speed to create these vaccines, and there are at least 270 more in development. But the Australian government's most significant deals are for the UK-created Oxford-AstraZeneca vaccine, as well as the option from Pfizer-BioNTech. We've got an order for 10 million doses of that vaccine. But most of our investment is with the Oxford option, a stock of 53.8 million doses. That order alone would be more than enough to vaccinate the whole population of 26 million Australians. But the two vaccines are quite different. Let's start with the Pfizer option. The Pfizer vaccine requires 2 doses taken 3 weeks apart. Results show it's 95% effective. Each dose costs around $25 to produce. It uses what's called a messenger RNA, a genetic material our cells read to make proteins. In this case, the same protein as the spikes on the coronavirus. To protect the RNA as it passes through the body, the scientists wrapped the genetic material in a bubble of fat. Once inside the body, the particles are swallowed up by the cell before fusing to the cell membrane, releasing the RNA. That cell then starts to build the spike protein that moves to the surface of the cell, where they're displayed for our immune system to see. Immune cells, called B cells, recognize the spikes as intruders and lock onto them. Once locked on, the B cells are instructed to make antibodies that will fight the spikes. But our body isn't done yet. Another part of our immune system, the helper T cell, supercharges those B cells, helping them make more and more antibodies. This process can turn a good immune response into a great one. The antibodies float around inside us until the coronavirus comes along. At that point, the antibodies recognize the spikes and latch onto them, rendering the virus useless and preventing it from attaching to our healthy cells. The Oxford-AstraZeneca vaccine goes a different way to get an immune response. Its effectiveness has varied in tests anywhere between 60 and 90%. It also requires 2 doses. The ideal delay between injections is still being determined, but around 4 weeks has been the standard. The cost of each dose is $5. But there are 2 key differences with the Pfizer vaccine. First, rather than using the delicate single mRNA, it uses double-stranded DNA to encode the instructions for the spike protein. Secondly, scientists have taken those instructions and packaged them inside the shell of another virus instead of the oily bubble. In this case, they've used the shell of an adenovirus, one of the viruses that causes the common cold. Once the adenovirus meets a cell, it infects the cell and gets inside quickly, making its way to the nucleus where it starts to make lots of RNA. From here, it's a familiar story. The spikes push to the outside of the cell, the B cells lock onto the spike and begin pouring antibodies out. The big difference between the 2 vaccines is that the double-stranded DNA in the Oxford version, along with the virus shell, is much stronger than the single RNA of the Pfizer vaccine in its oily bubble. That's why the Oxford option can be kept at between 2 and 8 degrees, while currently the alternative needs to be protected at very cold temperatures of nearly -70 degrees. That'll make it faster to roll out because it can be handled by a wider range of outlets such as GPs and even pharmacies. The vaccines should stop you getting sick if you've caught the virus, but we don't know yet if they'll stop it being passed around. Just like the flu, we'll likely live with this virus for a long time to come.
It's called